All right, welcome back. Today we're going to be going over the neuromuscular junction. So I know this looks like a really loaded picture of what's going on, but I broke down everything step by step to make it really easy to understand. If you understand what's going on in this picture, that's fantastic. If you don't, well, that's what this concept overview is for. So before we get to business, let me explain what's going on. What is the neuromuscular junction? So what it is that we're trying to communicate a message from a neuron to a muscle, hence the neuromuscular, right? Neuro meaning neuron and muscular mean muscle. It's the junction. So this is how you move your arm, for example. Our neuron needs to speak to our muscle cell, and that's how we move stuff. If you want to flex your bicep, for example, well, the signal comes from the brain, goes down the neuron, and goes to the muscle, so you can actually contract. This is the mechanism behind it, a partial mechanism. So let's get started. The first thing is an action potential needs to be generated. It needs to go down the neuron, and it reaches the axon terminal. So the action potential arrives to the axon terminal. Nothing but the muscle yet. It's the first step. Really easy. Second step. So the action potential causes voltage-gated calcium channels to open. Okay, so you see we have a calcium channel, and it opens. And calcium rushes in. So calcium is rushing into the axon terminal. So a lot of calcium here. It's rushing in. Okay? So far, so good? Now is when it's going to get a little busy here. Don't worry. So calcium is going to cause exocytosis of the vesicles. And these vesicles are holding acetylcholine. Okay, so acetylcholine is the neurotransmitter you need to be concerned about here. Very, very, very important. It's acetylcholine. So this calcium, so there's what's basically happening is there's acetylcholine in these vesicles. They're trapped like little bubbles inside the axon terminal. When calcium is inside the axon terminal, it causes acetylcholine to be released. Okay? It causes acetylcholine to be released in the synapse. So this is called the synapse. Or synaptic cleft. We call this synaptic cleft. Sorry. Synaptic cleft. If it's between a neuron and a muscle, we call it synaptic cleft. From neuron to neuron is synapse. So acetylcholine is released into the synaptic cleft, basically the space between the neuron and a muscle, the adjoining muscle cell. The acetylcholine binds to a receptor for acetylcholine on the muscle cell. So acetylcholine is released and it binds to an acetylcholine receptor on the muscle cell. The name you need to really remember, because you'll probably be tested on this, is it's called a nicotinic receptor. So the acetylcholine receptor is also called a nicotinic receptor. This is its official name. Nicotinic is its official name. If you're going to be tested on it, it's going to be nicotinic. It sounds like nicotine. I don't know why, but it's nicotinic. So acetylcholine binds to nicotinic receptors on the muscle cell. Right, this is the muscle cell here. Okay? So far, so good. Okay. When acetylcholine binds to the nicotinic receptor, a sodium channel is going to open up and sodium is going to rush into the muscle cell. Right? This is our muscle cell we're looking at. Let me just write it here. Muscle cell. Sodium rushes in. Okay? That's all you need to know about the muscle cell for right now. That's it. All right. Now, acetylcholine is not going to be permanently binded to this receptor. It gets freed. There's also excessive acetylcholine in the synaptic cleft that's not being used up. They didn't bind. They're just not going to stay there permanently. They need to be broken up. So there's an enzyme called acetylcholine esterase. It sounds like erase. It's literally saying acetylcholine erase or acetylcholine esterase. What this is going to do, this enzyme, so acetylcholine esterase is an enzyme, and it's going to break down acetylcholine. It literally karate chops it in half. Acetylcholine is going to break out into a molecule of acetate and a molecule of choline. So CH is choline. I just abbreviated it, but let me write it out. Choline. Actually, let me do it in red. Choline, okay? Choline. Okay. It's an E. Sorry, my E's are really bad. I know. E. So the acetylcholine esterase takes the excessive acetylcholine or the acetylcholine that's already been used up and bind it to the receptor. Now it's done. It's useless. So the acetylcholine esterase is literally going to karate chop it, and split it in half into acetate and choline. Okay? All right. So now, what you know is the choline is going to go back into this axon terminal here, right? So we had our choline here that we karate chopped, and it's going to go inside. It's going to go and make its way inside. The acetate goes bye-bye. We don't care about it. I don't know what happens to it, but something happens to it. We don't care. Not important. It literally just goes off to space or whatever. Not important. We only care about choline. Poor acetate. So, choline goes in. There's a mitochondrion, so that's singular. Mitochondria is plural. So in the in the axon terminal here, there's a mitochondrion, and it's constantly producing acetyl-CoA. Okay, this acetyl-CoA is going to bind. It's going to basically merge with the choline molecule we recycled. Okay, so we recycled, right, our choline molecule. It's going to go inside, and it's going to bind with acetyl-CoA from the mitochondrion. The mitochondrion makes this. It's like a factory. Okay, when these two combine, when acetyl or acetyl binds with choline, it literally makes acetylcholine, right? So acetyl, right, is this part. Acetyl, choline is this. That's acetylcholine. And that's ACH, right? What we use to bind to muscle cells. The CoA, or coenzyme A, that's what it stands for, literally goes back in the mitochondria to be recycled. We don't use it. All it is used to transport this acetyl molecule to the choline. And the acetylcholine just goes back into the vesicles, a fresh made new vesicle, and that's it. And then we're back to basically step one. Action potential, calcium, these vesicles, right? The acetylcholine was just generated by the mitochondrion, binds, sodium rushes into the muscle cell, acetylcholine esterase breaks it down, excess acetylcholine, we recycle the choline, the acetate goes bye-bye, the choline and acetyl bind to make acetylcholine. I hope this makes sense. So this is what this huge thing is. I broke all of this down into smaller steps. So now this would make sense, right? Number one, we got an action potential. Number two, we got calcium coming in. Number three, we got exocytosis of acetylcholine. Number three and number four are the same, or I merge them together so sodium rushes in at the same time. Acetylcholine breaks down, right, ACH, right, I should say, into acetate, acetate and choline. This choline goes here. Mitochondrion makes acetyl-CoA or acetyl coenzyme A. This combines with choline. We get acetylcholine, and the CoA that's from here gets sent back to the mitochondrion because you don't need it. And it goes back into the vesicle, and we start again. This is the neuromuscular junction. Hope this was helpful. Please like and subscribe. You guys have been awesome, and I'll see you later.